Lesson 4A is rather lengthy, so I'm going to record a lesson 5 where I will have finalized, I hope, adjustments to the shell. Students have been given poor information about this building, so we've had to augment it by studying other sources of data. So I want to also observe something about this facade that is significant visually. The floor slabs themselves project from the curtain wall, and they're probably more than 12 inches in thickness, and that so visually that we have to make adjustments for that. And we need a slab at this level, which we haven't got yet, at level 2. So I'm pretty sure that our mezzanine exists, yeah, inside of this 28 feet. So let's select the floor from level 3, copy it to the clipboard, and paste it aligned to selected level 2. It's overlapping an adjacent floor, which, if you remember, we drew in there, thinking it was representing the mezzanine, but the mezzanine actually happens somewhere in there. Let's edit that type and duplicate it and call it, I'm going to say these slabs are 24 inches. We can always adjust them afterwards. Give them a thickness. So that fixes that floor. We need to replace those two types, those two as well, with the one we just revit keeps most recently used types. They're convenient. These guys have to fall below. -4, -5. That's about right. These walls have to be extended upwards. We can also attach them, but again, they're not of consequence because they're sort of bounding. And then naturally the columns have to go to level 6. I could do these not L5 but level 6. Right. They hit level 6 and we'll have to attach them to that structure. Just going to select each column. Make them go up to level 6. Okay. We might as well attach the tops of these columns to this structure. Okay? So that means the top of the column will be aligned with the underside of that massive element, which may well be hollow back here, but that we're not concerned with that because we're not going back there. Walls from these levels need to be copied. Let's see. There's a wall on L5 that goes up to level 7, and we want to do these one level at a time, so let's make it go up to L6. The only exceptions are the walls that we have at the back, which we are just dragging upwards to meet the top of these buildings. I don't normally, my preference is to copy walls from floor to floor, but when they're not visually significant in the model, I think it's okay to just start at the base level and just to the back, because they just form that adjacency. Am I missing a floor slab there? Yeah, we're missing a floor slab at, let's tab over to that one. So we have one at L5, and this appears at L7. Let's copy it to the clipboard and try to paste it to where we think it's missing. L5, L6, align to selected levels. L6. Yeah, that's where it was missing. So now we have 1, 2, 3, 4, 5, 6 floors above the massive Doric columns. We still have to adjust the level to level height here. That's why those are uneven. Let's go to School Street and see if that's in fact what we have. We'll just crawl up the street a bit. One, 2, 3, 4, 5, 6. Wonderful. We have massive windows along this side. We have significant contour to the topography here, but we're ignoring that for now. But it's not trivial. It is significant, and it occurs in 2 directions. The high point, whoops, the high point, I don't know where I am, inside some kind of a let's look at a 3D view of the building. And notice that the massive structure at the top of School Street doesn't occupy the whole part, we also notice, and I admittedly am noticing for the first time, there's some empty space back there, and there's a second roof back here, and a two-story hen house, top of the building, parapet around it all, 6 stories above the massive Doric columns. So now we have that apparatus in place. Let's set an equal floor-to-floor height for 1, 2, 3, 4, 5, all these levels above level 3 old. So I'm going to go to elevation view. Put in dimensions. Between so these are floor-to-floor heights. I could set the quality here, but I don't want to do that. I want to measure it. 12.6, 12.0. What would happen if we made... No, it's not going to let me do that. So I should have done one at a time. So align dimension, explicit between levels, and you know, that should probably make level 11 top of parapet or something. Let's just change that. Top parapet. And that'll be the parapet wall around that we observed here. Right? That's to keep people from falling off the roof that are working on it. That's not actually what it's for. There are fire separation reasons for creating a parapet wall around buildings. Back to the model. If we decide that, let's measure the total distance floor to floor. That is, of those 6 stories. So we have 68 feet. If we divide that by 6, well, 72 would be 12. So 68 divided by 6. 11.3 floor to floor. This is important enough that show you how to do it. If you wanted to set equal intervals there, Revit allows you to create a string of dimensions. You got to be careful to make sure that you draw each one. Click and finish. And then if I click on this equal symbol, it distributes them evenly. It doesn't display the dimensions, so it's good to have drawn these others, so that tells you we have equal dimensions from floor to floor. That'll do for now. And then when we finish with the 3D walls, we want those walls to go to the top of the parapet. So I'm going to take those two walls, and one perpendicular to them. Copy them to the clipboard, and then paste a line to level 3, 4, 5, 6, 7, 8. Paste a line to selected levels. Remember, they're in the old building, so L6, L7, L8. I should really name all of these old. I'll do that. Okay. These floor slabs are coming up short. I'm not sure why exactly. We can make that adjustment. So, because I have that top of parapet, I can take those 3 walls and say top goes up to top of parapet. So that forms. It's probably a little bit intense. I need to modify these floors to make up for that space. Let's edit the boundary and bring it out. To that bounding wall. Finish edit. We could do the same. This wall. It starts on level 1, but we can make it just constrain the top of it to top of parapet and set the offset to 0. I'm going to do the same for that wall. That one, holding down the control key. Three walls selected. Up to top of parapet. Offset 0. Top of parapet. So we're in pretty good shape in terms of the general shell of the building now. So let's just go around the building shell to make sure we've accounted. Yeah, the curtain walls seem to have all the right constraints. There's a little gap in here. So that segment of wall, sort of a concrete. So because it's part of, really it's part of the new building, so it falls sort of in between levels. I think what I'm going to do is just take that and align it so it's sort of the gap in between the old level and the new level. We haven't dealt with what's going on that are drawn windows or glazing or other what other transparent elements that are drawn along the side of the building. We need a strategy for that. One thing we may do is make that wall that's recessed back there partly a curtain wall, and I think I will do that. So let's see where that floor is. That generic floor is on level 2 old, and I'm going to say that that wall, which is whose base constraint is at level 1, which is basically the ground plane, up to level 3 old. I'm going to make, I'm going to draw on level 1 a curtain wall up to level 3 old with and start drawing it at about 12 inches. And it'll automatically embed into this wall. Again, I'm drawing one segment of wall that's going to begin where this wall begins. It's going to be coincident with that wall, and it's going to have a sill of 12 because that's how I'm going to start drawing. So I go to level 1. The wall is still selected. You can see it there. You go to architecture, wall, curtain wall, base constraint level 1, base offset. I'm going to make that 12 inches, right? And up to level 3 old. Edit type, make sure it's set to automatically embed. It is. And I'm drawing from there to there. It's about 64 feet. So let's see what that looks like. You see what that does? We can modify that. We're going to have to deal with the gap between level 1 and the top of floor here, but I'm guessing, and you ought to be guessing at this point, that that is actually negotiated topography, right? It's a change in elevation of the site itself. So I'm going to set the base offset to 2 feet for the curtain. Well, it's more than that, huh? Let's set it to 3 feet, just to make up the gap in the floor. Then we're going to have to decide how we're going to negotiate that. You could do it with site, right? I could take, there's my top of surface, edit the surface, and start setting elevation points. I don't want to get into that just now because I don't want to confuse people, because there's a separate, but you can see that each boundary point for topography right now is set to 0, 0. If I were to raise that point or give it a different elevation, it would modify that and then express itself relative to the top of floor there. So I'm going to instead cancel that. Quit. Yes, I'm going to lose changes to that. So we still have, by the way, the curtain wall itself faceted along this side and then expressed as a single curtain wall along here. We have not yet divided it into a curtain grid and then modify that, created mullions from those grids. We haven't done that yet. We're just basically expressing the transparency of what's going on behind these columns here. The floors above, there's just windows that are going to puncture those openings. What's happening on this side? Let's go over to, let's look at School Street on that side. I think we can go down and see. So we have something of a massive multi-story, largely transparent element, but I'm not going to, we could call each of these, at least from level 1 to level 3, some kind of storefront curtain element with you know, a massive a spandrel panel that covers the thickness of the floor between them. So let's see if we did that, what would happen. We have these intervals where we have, oops, let's go back. It's possible that that drawing is correct on the drawing. Let's examine the drawing. So someone has approximated I'm going to create a few dimensions here. Someone's approximated the distance I need an orthogonal view to do this. So let's go to an elevation view. That is orthogonal to the CAD drawing itself. So there's a CAD drawing. We placed it. Doesn't matter where it is right now. Just sort of, and then it's got these elements in the bottom there. So they're saying 9 feet and then 13 feet. And I'm going to say that's quite wrong. I'm going to say that we're looking at about 4 feet above level 1. It varies. And then all the way to the underside of level 3. So that would be, everybody understand that? I'm drawing this entire element, 1, 2, A, B, C, D, if you will, rectangular, as a model as a rectangular curtain wall. Let's go to Revit. And the drawing should actually look more like and express it in detail lines. Let's create a detail line that we can use. I'm going to go to Manage. Line style. I'm going to add a red. A new line style, red line, wide. Assign it the color red and make it wide, 5. Assign it a line weight of 5, okay. And then we'll draw with it. wide red line. So actually what I need is more like this. Which is a difference between level 3 old, the underside of level 3 old, and in this case 7 feet above the ground plane. 9 feet, let's use that, 9 feet by 25. I'm going to draw on level 1 and start at a height of about 7 feet. And then draw each of these wall elements. Remember that. Double click level 1. I can't see each here, but I'm going to architecture, wall, this curtain wall, I'm going to set base offset to 7 feet. It's going to draw up to level 2, level 3 old less. To make that 25 feet, I'm going to set that to top offset of minus the difference, right, minus 4. So now when I draw in this direction, 9 feet, it's warning me that elements are not visible because it's climbing way up out of this view. That's okay. Let me explain that a little bit better. Floor plan, you're typically, the cutting plane is 4 feet above the ground. Because I asked Revit to start drawing at 7 feet above the ground, I can't see it here. However, if I were to go to my 3D view, I can see what I've drawn in the correct place. So I think what I want to do is basically just array this across here. There does seem to be evidence of intervals, and the intervals seem to correspond with those grid lines. Let's go back to level 1 and see if the drawing tells us anything about that. No, the grid lines don't really help us. Let's do this. We're just going to count. Let's guess that this is correct. I mean, not 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 of these across there. Let's look at the site itself. Can we count 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it did something right. Taking that element, I'm going to array it. From midpoint in that direction, let's see if I draw it 90 degrees. Let's try 1 and see what happens. No, that's no good. So it means that somehow that wall is not parallel, is not perpendicular to, whatever it's measuring from. So I'm going to have to do this differently. What I could do is start drawing maybe from a different level where I can actually see the curtain element. Level 4, I don't see it. Level 3 old, level 2 old. Okay, I can see it at level 2 old. I'm going to array it. So why can I see it at level 2 old? Because level 2 is above level 1 where I started drawing. I offset it to 7 feet above that, so the level 2 old is cutting through the element itself. So now I'm going to array in this direction. I'm going to group and associate. Nine. So 9 goes beyond it. I think it's when you let's see what we've drawn so far. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's change the interval 7 feet. Okay, that's not good. So if I activate dimensions of that array because it's grouped, I can set the interval to something different. Set it to 5, it seems to fit if I set it to 4. Let's go to that view again. Does that appear too close? So this is telling me that it is, well, it begins, it's a pretty massive interval between the first between the first of these, and then a small interval between the windows. So let's back to the model, activate dimensions. I'm going to say that might be about right. I have 4 feet between the elements. And I think we have about 11 feet from either end. 10.6. I'm going to say that's close enough. Yeah. So that's what's going on the ground floor. So it's largely the interface between the inside, the interior of the building and the exterior. And basically what we've modeled is we're saying when we're standing in here, we can see outside, you know, through this series of windows over here, through this facade over here, through this largely transparent space over here. And we're saying that the floor level here is 4 feet above the floor level here. Okay. That's 40 minutes. And we need at some point to decide on the window openings themselves in these upper floors.